Solve the inequality. Describe the solution set as an inequality in interval notation and in a graph. So the inequality that we're going to be solving here is 3x minus 4 is less than or equal to 8. And so we're going to proceed with solving this just like we would do if it was an equal sign here instead of an inequality. The only thing we're going to have to be on the lookout for is if we end up dividing or multiplying both sides by a negative number. And so if we run into that situation, we'll talk about that when we get to it, but we're going to start off just treating this as if it was an equation. We do want to be careful, though, that we keep this inequality in place. There can be a temptation when we work our process to start writing it as an equal sign, and we want to be sure that we don't do that because it's not an equation, it's an inequality. So to solve for x, the first thing we're going to need to do is we're going to need to add 4 to both sides of this inequality. So we'll do our add 4 here. The minus 4 plus 4, those are going to cancel out, and that's going to leave me with 3x on the left side. My inequality is going to come straight on down, less than or equal to, and then 8 plus 4 over here is going to give me 12. Now, x isn't alone quite yet. We still need to get rid of this 3 because the 3 is attached by multiplying. We're going to divide both sides by 3. So divide the left side by 3 and the right side. Over here, the 3's are going to cancel out, and that's going to leave us with x is less than or equal to 4. 12 divided by 3 is 4. So this gives us our solution as an inequality. Now we also want to write it in interval notation and in a graph. I'm going to go ahead and do the graph first because I think it's much easier to come up with interval notation once we have the graph in place. So we want to graph x is less than or equal to 4. So on my number line, I want to be sure that I put the number 4 on here. And I always want to be sure that I have at least one other number that I can relate to. Sometimes it's good just to put a 0 on there, just to kind of orient this in relationship to 0. And we want x is less than or equal to 4. Because it's or equal to, we're going to use a solid dot on the 4. We don't want to use an open circle. We'll use a solid dot because of the or equal to. So that's the solid dot symbol. And we're talking about the x's that are less than or equal to 4. So that means we're going to be going to the left. Also notice the inequality is pointing to the left. So that means that we're going to be going to the left on our number line this way. And once we have our graph in place, now we can set up our interval. When we say how far to the left does this go? Well, we can see that it goes forever to the left. There's no stopping this inequality as it proceeds down the number line to the left. So it's going to go all the way down to what we would call negative infinity. So that's that sideways 8. How far does it go to the right? It goes to 4. So 4 will be the right-hand number in my inequalities or in my interval notation. The 4 was included, right? It was the or equal to, it was the solid dot. So we're going to use the bracket, the brace here, the solid bracket. And to the left, we have this negative infinity. And whenever we're dealing with infinity or negative infinity, we can't talk about it being included because it's not really a number, it's more of an idea. So since it's not technically included, we're going to use the parenthesis. So there's the interval notation for the solution set of that inequality.